Hello, everyone. We are now on our module 6, naming hydrocarbons, specifically alkanes, alkenes, and alkynes. For this lesson, we'll be uh, naming hydrocarbons based on IUPAC conventions. So we should be able to draw the structures of hydrocarbons. To name hydrocarbons, we should know the root words and the suffixes that will represent the type of hydrocarbon. So, what are these? Here we have a table of root words and suffixes. So, for the root word, this represents the number of carbons. So, for a compound or hydrocarbon that contains one carbon, the root word will be meth. For two carbons will be eth. Then for three, prop, and so on and so forth. So you just use all the root words that exactly represents the number of carbons in the compound. Then you will combine it with the suffix on which type of compound you are dealing with. So if you're dealing with an alkane, you add ane to the root word. So for example, for one carbon alkane, you will have a name of methane. For three carbon alkane, we will have a name propane. So for five carbon alkane, we will have pentane. So you just add the root word and suffix. So we also have another suffix in. So that's the suffix for alkenes. So basically, you just take the last three letters of the word from the words of hydrocarbon alkane, alkene, and alkyne. So those will be your suffixes. So here are some examples. So for example, we have methane, butane, hexane. Then we can have also propene, hexene, or nonene. Or we can have for alkyne, um, butane, hexane, or alkyne. So these are some names or hydrocarbons which is the result of combining the root word and the suffix. So please take note of this table because you will be using this from time to time, especially when we are naming hydrocarbons. But for alkane and cycloalkane, we have the general formula of CnH2n plus 2. So this is applicable for all alkanes. So from 1 carbon to 10 carbons, we have this general formula. They all follow this general formula. For cycloalkane, since it's a cyclic structure of hydrocarbon, there will be less hydrogens in its structure. So CnH2n is its general formula. They have these rules to follow. So the first rule is count the number of carbon in the chain and identify the corresponding root word. So from the table previously, we can identify what is the root word that will represent the structure. or the compound. So we have the root word plus ane. So that's the name of the alkane. And for cycloalkane, we add cyclo as a prefix to the root word. Then we also have ane as its suffix. So this is the pattern of naming this hydrocarbon. So we have here the figures, example figures. So for the first figure, we have to count the number of carbons in its structure. So we will number them. So the first figure have 1, 2, then 3. So we have 3 carbons in this structure. So from the table previously given, what's the root word that represents 3 carbons? It is prop, right? So you will write down the root word prop. Then, since it's an alkane, you'll aim to its root word. So propane will be the name of this compound. So we have 3 carbons and it is an alkane. So the name of this compound is propane. So let's proceed to the next figure. We have here a line angle diagram or structure. So to count the number of carbons, recall that carbons in this type of structure is located at the end points. So we have carbons here. We also have carbons at the intersections. So we have carbons here. So you will count the number of carbons. So we have 1, 2, 3, 4, 5. Then after counting the number of carbons, you will look for the root word that will represent this number. So that is 5, that will be pen. So you will write the root word pen. Then since it's an alkane, so the name will be pentane. Lastly, to our last figure, we have expanded structure. So we will again count the carbons. We have 1, 2, 3, 4, 5, 6. So there are 6 carbons in its structure. So the root word for this is hex. Then since it's an alkane, so the name will be hexane. So that's an easy way of naming this hydrocarbon or the alkane. So you just count the number of carbons and you will know the name of the alkane. Next will be some cyclic structures. To name cyclic structures, still the same principle. You have to count the number of carbons in the structure. Then you put cyclo before the root word and you put ane after the root word. Okay, so for the first figure, we have 3 carbons. That would be propane. So since it's a cyclic uh, compound, so we will write cyclopropane. Okay, then for the next one, how many carbons? We have 1, 2, 3, 4, 5. So that will be pentane. Since it's cyclic, you put cyclopentane. Lastly, we have one, two, three, four, five, six. So there are six carbons in the structure that will be hexane. Then since it's cyclic, you put cyclohexane. So it's easy to name this hydrocarbon because it's just very simple in identifying the number of carbons since there's still no double bands or triple bands in its structure. Later, we will have a more challenging task of naming the hydrocarbon if there are more, if there will be double bands or triple bands in the structure. So to have these types of hydrocarbons containing double bands or triple bands, let's go first to alkenes and cycloalkenes. So the general formula for alkenes is CnH2n. So as you notice, the general formula of alkenes is similar to the general formula of cycloalkane. Okay, so you should take note of that. But for this general formula, this is only applicable to alkenes containing one double bond in the structure. So applicable to alkenes with one double bond. If there are more double bonds, the hydrogen will have less numbers, so it will change the general formula. So for this general formula, this is only applicable to one double bond. For cycloalkanes, since it's um, cyclic, there will be also varying number of hydrogen atoms depending on the number of double bonds. Okay, so let's proceed to the rules in naming alkene. So in naming alkene, you should take note of this. So the name will be, you'll be having the double band location. Next to the location, there will be a hyphen, then root word, then plus suffix. So later we will be seeing how we write the name of these alkenes. So another rule, count the number of carbon in the chain and identify the corresponding root word. Then, number the carbons starting from the end carbon nearest to a double bond. So, the goal of this is to have small numbers as bond locators. So, that will be our very goal, to have small numbers as our locators. Then locate the double bonds in the chain using the numbers of the carbon. So here, for example, so again, goal to have small numbers as band locator. We have these figures as our examples. So for the first figure, first step will be you will be numbering the carbon. So the question is, which carbon should you start writing? From left to right or right to left? From the rule, again, start numbering from the carbon nearest to the double bond. So we will not start from the right. We will start from the left because the carbon at the end point or the end carbon is the nearest carbon to the double bond. So we will start numbering here. 1, 2, 3, 4. Okay. So there are four carbons. So you now know the number of carbons present in the structure. Now, identify the root word of this carbon, or you can identify what kind of alkene. So we have four carbons. The root word will be but. Then we have a suffix in since it's an alkene. So the root or the chain name of this is um, butene. That's the name of the chain. Okay. But we should know the location of the double band. So we will write the location of the double band. So here in this example, the location of the double band starts at carbon 1. So carbon 1 will be the location of the double band. Okay, why not 2? Again, our goal is to have a small number as band locator. So we will not write 2 because it's greater than 1. So 1 is lesser than 2, so our goal will be achieved to have a small number as band locator. So the name of this hydrocarbon is 1-butene. Okay, next, another example. We have this. So again, number the hydrocarbon starting from the carbon nearest to the double band. So in this case, the carbon nearest is at the right side. So we will start numbering at the right side. So 1, 2, 3. So we have 3 carbons. So these carbons will represent the root word, is represented by a root word prop. So the name of this chain will be propene. Okay. Then you write the location of the carbon or double band. So again, the goal is to have small numbers as band locator. So between 1 and 2, we have 1 as the smallest number or smaller number. So the name of this hydrocarbon or this compound is 1-propene. Okay? So that's how you name alkenes with one double bond. Okay? Then again, double bonds can be located at other carbons. So for example, we have a longer chain. Say we have this structure or skeletal formula. So C, double bond C. So there are four carbons. So the name of the chain will be butene. But the double band is located at where? So since this is a symmetrical um, structure, so we can start anywhere from right to left or left to right. So we will now 1, 2, 3, 4. The double bond is between carbon 3 and carbon 2. So which one is smaller? So you will choose 2 as the smaller value. So you will write that as butene is the name of this structure. Again, the goal is to have small numbers as band locators. We also have rules for cycloalkenes. So the same, count the number of carbon in the ring and identify the corresponding root word. So Corresponding root word will be the table presented earlier. So for cycloalkanes with one double band, no need to locate the double band. However, if it has two or more double bands, it is necessary to specify their locations. For example, we have these structures. So in the first figure, let's zoom in. In the first figure, we have to count all the carbons in the ring. But where should we start? So we will start counting from, oh no, but this cycloalkene has only one double band, so no need to put locators. You just need to identify the number of carbons in the ring since it only has one double band. So you can also write the numbers, let's say 1, 2, 3, 4, 5. So that represents the number of carbons in the ring. So what is the root word or the name of the ring hydrocarbon or cyclic hydrocarbon? That will be pentene. If it's a straight chain, but since it's cyclic, you will write cyclopentene. Okay? As you notice, the name don't have um, any uh, double band location. So since it only has one double band, no need to specify the location of that double band. Same with the figure number 2. You just need to count the number of carbons. So to count the number of carbons in this structure, we have to locate those carbons. So we have a carbon here, also here, 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 and also here, lastly here. So you have to count those carbons. So how many carbons? That will be 6 carbons. So if we number it, we have 1, 2, 3, 4, 5, 6. So the name of a straight chain alkene with 6 carbon is hexene. That's for a straight chain. But since it's a cyclic uh, alkene, the name will be cyclohexene. Connected, the uh, cyclohexene is a one word. So there's no dash between, there's no space between. So sorry for that space, but the name will have no space or no dash or hyphen. Okay. So again, for cycloalkene with only one double band, no need to specify the location of the double band. Okay, another special rule for two or more double bands, use prefixes di, tri, tetra, etc. to represent the number of double bands. So the root word ends with A. So you will add a letter A to the root word. Example, buta, penta, and etc. So from our previous example, our root word only don't have letter A at the end. So we usually say but or pent. But now, since in this case we have two double bands, two or more double bands, we will add A at the end of the root word. So for example, we have this structure. So first step, count the number of carbons in the structure here. So again, the goal is to have small numbers as band locators. So in this case, where should we start? Again, to number carbons, you start at the and carbon that is nearest to a double band. So which side has or is near to the double band, to a double band? Is it the left side or is it the right side? So in this case, the right side is the nearest one to a double band. So carbon here, so you should start at the right side. So you will number here carbon 1, carbon 2, carbon 3, carbon 4, and carbon 5, carbon 6. So there are 6 carbons in this structure. Now, what is the name of the chain? So this is an alkene with 6 carbons. So the name will be hexa. So from our rule above, the root word ends with a. Okay. So hexa. Since there are 2 double bonds, we will use the prefix di. So we will put hexa, di, then suffix in. So hexa, diin. So hexa root word, di prefix, then in is the suffix. So the hexadiene is the name of this chain. Now, after identifying the name of the chain or the longest chain or parent chain, you identify the location of the double bonds. So the double bonds are located at which carbons? The first double bond is located in carbon 1 and carbon 2. Which one is smaller, 1 or 2? So we will use 1 as our location. So you write 1. The second carbon is located at carbon, no, the second double bond is located at carbon 4 and carbon 5. So you will use 4 as our location. So 4. So 1 and 4. We will separate the two locations with a comma. So numbers will be separated by a comma. Then number and words will be separated by a hyphen. So we will also write a hyphen here. So 1 comma 4 hyphen hexadiene. That will be the name of our hydrocarbon. So 1, 4 are the location of the double bonds. Hexadiene is the name of the chain. So there are 2 double bonds. That's why we use di. Okay, another example. For for cyclic alkenes or cycloalkene. So in here, first step is to number the carbons. In here, it is tricky because you might be confused where to start. Okay, so for this case, we will number the carbons based on our goal. So our goal is to have small number locators. So in this case, we can start at this carbon. So we can start here or we can start here. We cannot start at the other points because it will lead to bigger numbers of locators. So in this case, I will choose at the right side. So I can start numbering here 1, and I'll be numbering counterclockwise 2, 3, 4, 5, 6, 7. So these are the numbers of the carbons. So what is the name of the hydrocarbon or the ring? So since this is cyclic, we are expecting to have a cyclo as prefix. So we will write cyclo. Then there are 7 carbons. That will be hepta, there's an A. And how many double bonds? There are three. So that will be tri, then in. So cycloheptatriene is the name of the ring. Then the location of the double bonds will be from carbon 1, carbon 3, and carbon 5. So carbon 1, carbon 3, and carbon 5 are the locations of the double bond. Again, we are making the numbers as low as possible. So 1, comma 3, comma 5, then there's a hyphen. So 135 cycloheptatriene is the name of this compound. Okay? So again, take note of the rule. For two or more double bonds, use prefixes di, tri, tetra, and others. Then to represent the number of double bonds, then the root words ends with a. Okay, that's why we have these examples. Okay, let's proceed to alkynes. So for alkynes, we have the general formula CN H2N minus 2. Okay, this is also applicable only when there's only one triple bond. There's one triple bond on the structure. There are more, it will affect the formula of the hydrogen. So it will vary. It will change the value. Same cycloalkyne, number of hydrogen atoms varies on the number of triple bonds present in the structure. So the rule for this will be the same to the naming of alkenes. So what is being discussed from the alkenes, what was being discussed will be the same rules applied to alkynes. The difference is only on the suffix. So for example, we have this. So the suffix for alkyne will be "-ine". So from alkene, you will just change it to "-ine" since it's a triple bond. So here for an example, you count and number the hydrocarbons present in the structure. So start from the carbon nearest to the triple bond. So which side, from left or right? So in this first figure, since it's symmetric, so no need to choose from which side. You can choose arbitrarily or anywhere. So we can start from right or we can start from the left. So here we can, I will start from the left side. So 1, 2, 3, 4, 5, 6. Okay, these are the number of carbons in the structure. Now identify what's the name of this chain. Since it's an alkyne, you will have a suffix "-ine" with a root word with 6 carbons. That will be hexyne. Hexyne. Okay, wait. We have a double band. So we have double bands. So it will be different because we have double bands. So let's try that again. So let's number the carbons. 1, 2, 3, 4, 5, 6. Since it's a double band or a triple band, there are there are two triple bonds. So the name will have prefix di. So the root word will be hexa. Then we have prefix di, then ein, hexadiene, hexadiene. Okay, so that's the name of the chain, hexadiene. But we should also locate the triple bonds. The triple bonds are located in carbon 2 and carbon 4. Okay, we'll write hexadiene, hexadiene. So 2,4 hexadiene. Okay, for the next figure, we have this structure. Again, we have to count the carbons. So in this case, the carbon nearest to a triple bond is from the left side. So we will start numbering to the left side. Left side. So 1, 2, there's a carbon here. There's also a carbon here. That will be the third one. Also a carbon here. 4, here, 5, also here, 6, then 7. So there are 7 carbons in the structure. So the root word will be hepta, and after it, there are 3 triple bonds. So we will use tri, then the suffix y and e. Heptatriene. Heptatriene. Okay, heptatriene. Okay, then the location of these triple bonds. The first triple bond is located at the first carbon. So here, the second one is located at the third carbon, and the third one is located at the fifth carbon. So these are the locations of the triple bond. So you will write 1, 3, 5, then dash or hyphen. So 1, 3, 5 heptatriene is the name of this compound. Okay. So basically the same rules with alkenes but differs on the suffix used. So in alkene the suffix is in alkyne the suffix is "-ine" or "-yne". So the same rule for alkene. For cycloalkyne, um, the rule is the ring must have high number of carbons for it to exist. Cyclooctane is the smallest cycloalkyne capable of being isolated and stored as a stable compound. So this is the simplest or the smallest cycloalkyne, which is cyclooctane. So going up will be the uh, other members of the cycloalkyne family. So it starts at cyclooctane. So the structure of the cyclooctane is like this. So again, you don't need to specify the location of the triple band since there's only one triple band in the structure. So you just count the number of carbons. So in this case, there are, so let's try to count 1, 2, 3, 4, 5, 6, 7, 8. So this is the cyclooctane cyclo, since it's cyclic, then oc as the root word, then "-ine" as the suffix. So cyclooctane is the name of that structure. Next, so we have now the rules in naming simple alkanes, simple alkenes, and simple um, alkynes. Those are unbranched chains, meaning there are no side chains or any branching within the structure. So, what if we have branched structures? So, what do you mean by branch? So, for branch structures, literal meaning there are branches of hydrocarbons or some groups that is being attached to the hydrocarbon. So, one of these is the alkyl group. So alkyl group is formed by removing one hydrogen from the alkane chain, and the removal of this hydrogen results in a stem change from ane to -il. So it's derived from the alkane, but since you remove one hydrogen, it becomes an alkyl group. So that alkyl group will be attached to another hydrocarbon, either an alkane, it can be attached also to an alkene or an alkyne. So alkyl groups can be attached to the three types. Even also it can be attached to some cyclic hydrocarbons. So it can be attached to a cycloalkane, it can be attached to a cycloalkene. Okay? So in naming this alkyl group, we should know how to derive the name of the alkyl uh, group. So from methane, if we remove one hydrogen, we will have this structure, CH3. So CH3 is derived from methane. The name of this will be methyl. R will be the chain we will be attaching our alkyl group. So R is our main chain or parent chain. So we will be attaching the alkyl group. Another one, propane. If you remove one H from the end carbon, so we can have this structure, the propyl group attached to a chain hydrocarbon. So R is the parent chain hydrocarbon. Okay, some of the examples are this. So here's a table, structural formula for one carbon, CH3. So the name of this will be methyl, two carbons, ethyl, three carbons, propyl, four carbons, butyl, and five carbons, pentyl. And also six, there's a six. So the name of that will be hexyl, and so on. There's still some um, names after six, depending on the length of your uh, hydrocarbons. So more carbons present, you can have more uh, alkyl group attached to the structure. Okay, let's have an example. Let's take a look at these structures. In structure one, we have this chain. We are using the skeletal formula for us to have a simpler view of the structure. So we have here carbons attached. So as you notice, we have five carbons. So to name this hydrocarbon, the first step is to identify the longest chain. So in this case, our longest chain, we can have this as our longest chain, or we can also have this as our longest chain. So it is not necessary that our longest chain is linear. So it can be bending at one side. So it can be uh, branching at either side as long as the chain is continuous. So the red line, the chain is continuous, that is a straight line or a straight chain. Then the green chain, that's a bending chain. So we can have that also as our longest chain. So since it's an alkane, it doesn't matter which one is your longest chain. Okay. So now we have identified the longest chain. So I'll be using the first choice. We will be using this one as our longest chain. So we will now number the carbon. So after identifying the longest chain, number the carbons on that chain. So which way or which carbon should you start numbering? So that's the second rule. The first rule is to identify the longest chain. The second rule is to number the carbon starting from the end carbon nearest to a substituent. So alkyl group is our substituent. So which end carbon is near to the alkyl group? So this is the red line is our longest chain, and this will be our alkyl group. Okay. So which carbon in the longest chain is near to the alkyl group? Is it from the end carbon here, or is it the end carbon here? So of course, it is the carbon at the right side. So we will start numbering at that side. So we write 1, 2, 3, 4. So we started at the right side since this carbon is near to the alkyl group. So the first alkyl group encountered, uh, that carbon will be the number or will be the starting carbon. So here we started at this side. So we will now have the numbers of the carbon of the longest chain. So we have 4 carbons in the longest chain. So after numbering, you name the longest chain. So what's the name of the longest chain? It's an alkane with 4 carbons. So the name will be butane. Okay? That's the name of the longest chain. Now, since we have an alkyl group attached to butane, we will also add that alkyl name to our hydrocarbon name. So where should we put it? We will use it as a prefix. So what's the name of this alkyl group? Only one carbon. So that will be methyl. That's the name of the alkyl group. So we will add this as a prefix to our longest chain. So we write methyl. So that's one word, methyl butane. Then the location of that alkyl group, where is that located? So you will look at the number you assigned earlier. Methyl is located at carbon. So you write 2 hyphen methyl butane. So 2 methyl butane. So that's the name of the structure. So 2 methyl butane. 2 represents the location of alkyl group. Methyl is the name of your alkyl group. Chain is the name of your longest chain. Okay, let's proceed next. Let's take a look at this. To name this, again, we will start with the step one. Step one is to identify the longest chain. So which one is the longest chain? Is it this chain? Is it this one? Is it this one? No. The two choices are not the longest chain, but our longest chain is group of carbon atoms enclosed in the green line, within the green line. Okay, so I'll erase the markings. So we will use this as our longest chain. Okay, number the longest chain. So where should we start? Should we start at this point or should we start at this point? If you compare the location of the methyl group, the point is the nearest carbon to the methyl group. So we have, if we number it, 1, 2, 3. So at the third carbon, the methyl group is attached. But if we started numbering at this point, 1, 2, 3, 4, it will give us a higher value of our number locator or the location of our methyl group. Okay, so we will start numbering at this point. So 1, 2, 3, 4, 5, 6. As you notice, our longest chain is not a straight chain. It is bended or it is at a right angle if you want to say that. But make sure that your longest chain is continuous. So meaning they are connected with each other. There are carbon bonding. So here we have 6 carbons attached all together. So that is our longest chain. The name of that parent parent chain or the longest chain is what? That will be hexane. That's the name of the longest chain. Now, what's the name of the methyl group? We have this as our methyl group or alkyl group, which is methyl. The name of our alkyl group is methyl. So name or chain. So methyl hexane is one word. So that will be the name of the uh, structure. Then the location of the alkyl group is at what carbon? So you look at the numbers. So it is located at carbon 3. So you write 3 dash. So always remember dash or hyphen separates the number and words. If there are two locations, it will be separated by a comma. So in this case, there's only one location of or one meth or one alkyl. So I'll just use or no comma. So I'll just use dash as a separator between number and words. Okay. So the name of this structure is 3-methyl hexane. So again, 3 is the location of your alkyl group or substituent. So our substituent name is methyl. Then our parent chain is hexane. Okay. Let's move on to the next example. We have this line angle formula. Should be a very challenging example. Okay, first task, identify which chain is the longest chain. So in this case, our longest chain will be this. Okay, this will be our longest chain. So how many carbons involved in the longest chain? So you count the carbons in that chain. So we have here, carbon here, a carbon here, so a carbon here, carbon, 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 and a carbon. So how many carbons? One, 2, 3, 4, 5, 6, 7. Okay. Once you identify the longest chain, you number it. So which end point or which end carbon is nearest to a substituent or an alkyl group? So which one is nearest to a substituent? So it is nearest the first substituent or a substituent that is near to an end carbon is this one. This is our one substituent. It is near to that carbon. So we will start at that carbon, numbering it from 1, 2, 3, 4, 5, 6, 7. We will not use this as our basis because it is far from the end carbon. So we will use the circled one as our basis to where we should start our number in the longest chain. Okay, now you've identified the longest chain. What's the name of that chain? So we have 7 carbons involved. The name will be heptane. That's the longest chain. Then what's the name of the alkyl groups? We have a group here below and a methyl group above. So since there are 2 methyl groups, we will use a prefix di. If you have 3 methyl groups, you will use a prefix tri. So in this case, we have 2 methyl groups. We will use the word or the term dimethyl. So dimethyl meaning 2 methyl heptane. Okay. Then the locations of these alkyl groups. So the first methyl is located at carbon 3. The second methyl is located at carbon 4. So you will write 3, 4 dimethyl heptane. So 3,4-dimethyl heptane is the name of the structure or the compound. So again, 3 and 4 are the locators or the locations of the alkyl group. Di means there are 2 alkyl groups or there are 2 methyls. Then heptane is the name of our longest chain. Okay, next, another example here. So again, identify the longest chain. So our longest chain will be this. So enclosed is our longest chain. Okay. So how many carbons involved? So we have here carbon here, carbon here, a carbon, 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 carbon. So again, we have 2, 4, 6 carbons. So what's the name of that uh, longest chain? So 6 is hexane. After identifying the longest chain, um, number the carbons in it. So where should you start? Okay, in this case, since we have three alkyl groups, there are three alkyl methyls. So at carbon, in this carbon, we have two methyls attached. So here, two methyls attached to a single carbon. So this will be our basis on where should we start our numbering. Why? Because there are two carbons attached in two methyl attached in one carbon compared to this methyl that is a single one. So we will prioritize these two as our basis on where should we start our number. So which end carbon is um, two methyl is end carbon. So we will start numbering the right side. 1, 2, 3, 4, 5, 6. Okay. So at the end, rest touch in a single carbon. So we will not start here. We will not start here because um, we prioritize the two carbon. Okay. So this is same. Then what's the alkyl groups attached to the longest chain? They are all methyl. So you should write tri. So there are three methyls: methyl, hexane. Then the location of this methyl. So the first two is located at E. We have meaning two methyl is attached to carbon 3. So 3,3,4 trimethyl hexane. That's the name of our carbon, a hydrocarbon or compound. Okay. So again, in this case, the priority is um, the group with two alkyl groups or two methyl attached to one carbon in the longest chain. Okay, that's for alkane. Alkyl groups as substituents for alkanes. Alkyl groups as substituents. Keys. So similar structure but differs at some points or at some points. So if you look at the structures, the first figure, the difference is there's double band. The second figure, there's also a double band. The third figure, also a double band. Then let's there's double band, two double bands present in the structure. So basically, they have similar um, structures, but they differ on the double bands present in the structure. Okay, to name this alkene, we will follow the same rule. You identify the longest chain, you number the carbons in the longest chain, and also name the longest chain, then identify the um, alkyl groups or substituent attached to the longest chain with their locations. So first one, you identify the longest chain. In the first figure, which one is our longest chain? Take note, we have a double band in the structure, and this double band will greatly affect the priority of your longest chain. So our longest chain now is our longest chain is this, the one containing the double band. So in alkenes, the longest chain is the one containing the double bands. Okay? So in this case, we will use this as our longest chain, the one containing the double bands. Okay. We start numbering our carbons from the carbon nearest to the double. Previously, we started numbering substituent encountered. Now, the priority number nearest to the double band. Okay? So, our carbon nearest band is at the, so we start here. So, one, so that's our longest chain. The name of this is the name, butene. Let me clear that one. Name of this longest chain is team. Okay? The longest chain has a double band, so we should also write the location of that double band. So the double band is located at the first carbon here. So 1 butene is our name of the longest chain. So 1 is the location of the double band, butene is the name of the chain. Okay, now we will name the alkyl group. So our alkyl group here is this example. So methyl, you will write that before the number 1. Since 1 is a number, we will separate methyl with methyl. So methyl 1 butene still lacking a location of, okay? So methyl is located on 2. So your methyl 1 butene. Okay? So the name of the structure or compound is 2-methyl 1-butene. So let's review the name of your substituent methyl. Methyl is the name of your alkyl group. is the name of the, or one is the location of the double band. Chain is the name of your longest chain. Okay. Next example here. Previously, chain is this one, right? But now, since we have a double band, we will not use it anymore as our longest chain. Again, reminder, the longest chain in alkenes will always the chain containing the double bond. So here, our longest chain will be this one. So we start numbering at the carbon nearest to the double bond. So we start at the right side. 1, 2, 3, 4, 5. Not the other way around. We will not start at the left side because if we start at the left side, we will have high numbers of our locators. Okay? Next, identify the name of that alkyl group, or no, longest chain. The name of the longest chain is pentene. Okay? Pentene. Then the double bond is located at carbon 1, so that's why we have 1 pentene. Then the name of your methyl group is, the name of the alkyl group is ethyl. Ethyl. There are 2 carbons, so that's ethyl. So you write that before 1, ethyl dash 1 dash pentene. Then the location of your alkyl group. So it is located at carbon 2. 2 ethyl, 1 pentene. Okay, let's review. 2 is your location of the substituent, ethyl. Ethyl is the name of your substituent. 1 is the double bond location. Pentene is the name of your longest chain. Okay, another example. This one. Similar figure but has a double band in the structure from the previous example in the alkanes. So previously, we used this as our longest chain, but since there's a double band added to the structure, it will now change the longest change. So again, the longest chain containing the double band is the longest chain, or the chain containing the longest or the double band is your longest chain. Okay, so in this case, the longest chain is this one. Okay, so the chain containing the longest, the double band is the longest chain. So our alkyl group are okay. We have 2 alkyl groups, one with 1 carbon, another with 2 carbons. Okay, so after identifying the longest chain, you number it. So starting here, because it's near to the double bond, 1, 2, 3, 4, 5, 6. So that's our longest chain with 6 carbons. What's the name of this? It is um, hexene. It's okay. We number it 1, 2, 3, 4, 5, 6. Name is hexene. Then location of the double bond is at carbon 1. Okay. Then what are the alkyl groups present in the structure? We have an alkyl group. We also have here an alkyl group. So what are the names of this? The first one is ethyl and the other one is methyl. Okay, in this case, we have two different alkyl groups. So which one should you write first? So as a word, as a whole word, or as a whole name, you write first the alkyl group that is that starts or that arranged in a order. Which one should you write? In this case, starts in the alphabet then M. So we will start writing our whole name ethyl, but do it backwards. We will add methyl at this part. Then methyl is at add the location of or the name of the second alkyl, ethyl, then location of the ethyl group, which is in carbon 2. So this will be the whole structure. 2, 2 is the location of the alkyl group ethyl, the location of the alkyl group methyl. 1 is the location of your double bond. Name is the name of your chain arrangement. So again, alkyl groups will be arranged okay. We will be arranging them alphabetically. So in this case, started ethyl, so 2 ethyl, 3 methyl. So the structure given of. Do not forget to arrange. So if there are prefixes, you will disregard the letter in the prefix. You will always based on the name of the alkyl. So in the case that we have dimethyl, we will not put at the first part of our word name. We will not use D as our M as our basis in computers. Complete. So if that's the case lang, here you will see an example of that. Another example, not identify the chain or longest chain for this example is this one. So after identifying the longest chain, you will start at the right side. because it is located at the end carbon. So 1, 2, 3, 4, 5, 6. So that's our longest chain. Our longest chain has two double bonds, so we'll be using a prefix di will indicate two double bonds. So our name of our longest chain is hexa di in. So hexa, 6 carbons, di, two double bonds in alkene. So the location of those double bonds are in carbon 1 and carbon 4. These are the locations of the double bond. Okay. Next, after identifying the longest chain, identify the alkyl groups attached to the longest chain. So we have three alkyl groups, all. So we have methyl here, and also a methyl base part. There are three methyls. Methyl, then the location of those methyls are in carbon 3. Two are located in the carbon 3, so that's why we E3. Then the last methyl is at carbon 4. So 3, 4, trimethyl, 1, 4, hexadiene. So let's review those terms. 3, 3, 4, of your substituents, the alkyl group. Trimethyl is the name of your substituent for an alkyl group. 1, 4 is your double bond locations. Hexadiene, the name of your longest chain. Okay. Next. So I hope follow the rules for alkene rule. So alkyl groups in alkene. So you should know the rules. So first is to identify the longest chain containing the double bond. Next, number the carbons in the longest chain and identify the name of the longest chain. Next, identify the location of the double bond. Next will be identifying the name of the alkyl groups. Then lastly, identify the location of the alkyl groups. So those are compound. So alkyl groups can also be attached to some compounds or hydrocarbons. So for this example, we have these two compounds for cyclic hydrocarbons or cycloalkanes. So in the first one, we have a cyclic and an alkyl group, a cycloalkane and alkyl group. So in this case, if there's only one alkyl group attached to a cycloalkane, no need to identify the location. Just combine the name of the alkyl group and cycloalkane. So in the first figure, the name of the alkyl group is methyl. Then the name of the cycloalkane is cyclopropane. So that's the name of our compound. Methyl, the alkyl group. Cyclopropane is the cycloalkane. So that's a very easy way to name this compound. Next one, methyl, then we have pentane. Okay, that's easy. Cyclopentane is the name of the um, cycloalkane. As you notice, there are no numbers. Again, there's only one alkyl. It was the number always starts at one. Where the carbon, the alkyl group, is attached to the carbon of the alkane and the alkyl group. So it always starts at this point. So one. So there's no specify. Proceed. So we can also have another example, but now we have two alkyl groups attached to the cycloalkanes. Previously, only one was attached. So in this case, since there are two, you will now specify the location of the groups. First step is to identify the name of the site. So how should you identify that? So you will count the carbons in the ring. So in this first figure, there are 6 carbons. We'll put indicators. There are 6 carbons. Will be cyclohexane. Okay. Next, identify or number the carbons in the ring. So to number cyclic hydrocarbons, you will see the ring. So wherever you want to start, since it's still a ring, there are dots. So you will choose which carbon. So in this case, there are two methyls, so the same kinds of alkyl group. So you will choose wherever you want it to start. So I can start one, or I can start here one. So whichever you prefer. So I can start here one, but the next number is going towards the next substituent. So what do you mean by that? Again, our goal is to have a low number as our number locators. So going towards the next substituent. So to have a small numbers or small numbers as our locator, so our action of numbering will be counter going towards the next um, alkyl group. So this will be the direction of our numbering. If we use the other direction, if we use it like this, it will result to a higher number later. So let's see the difference. Two, 6. Then I'll use another color for the other direction. 6. So for red numbers, as you can see, our alkyl groups will have small numbers, 1 and 3, compared to the green numbers, our alkyl groups will have big number. So the second one will have 5, 1 and 5. Okay? So we will use the red direction where it's in counterclockwise. Okay? So the name of the ring is cyclohexane. The name of the methyl is R2. Oops. I'll click. I will write the hexane. The name of the alkyl group methyl. So it's connected. Dimethyl cyclohexane is one word. Then the two methyls. So one is carbon 1 and carbon 3. Okay? So these are this is the name of the structure or compound given. So 1,3-dimethyl cyclohexane. Let's review these parts. 1,3 is the location of your alkyl group, which are two methyls. So cyclohexane is your cycloalkane or cyclic hydrocarbon. So that's how you name this. Another example here, we have a ring with 5 carbons. So you count the carbons, there will be 5. Then for this case, since the groups are not the same, we have F and methyl. Okay, the priority will be the starting letter, or you should arrange them in alphabetical order. So ethyl will go first. So we will start at the carbon attached to ethyl. So we'll start here. 1, 2, 3, 4, 5. We will not number the carbons in clockwise direction because if we put 1, 2, 3, 4, 5, our substituents will have big numbers. So our goal is to have small numbers as our locator. So we will not use that one. So not recommended, not recommended, not recommended, not recommended. So we will use this one. Okay. So what are the names? The name of the cycloalkane is cyclopentane since there are 5 carbons in the ring. Next, since we will start with our name, we will be starting with ethyl. We will write methyl as our second substituent. So we will write here methyl. So next is the location of methyl, which is in carbon 2. Then next will be ethyl. Then the location of ethyl is carbon 1. So this will now be the name of our hydrocarbon. 1-ethyl, 2-methyl cyclopentane. As you notice, these are arranged in alphabetical order. Ethyl, ethyl. So EM. So alphabetical ang yung order. So start with letter is appearing earlier in the alphabet. So that's why we started at 1-ethyl. Ethyl, methyl, cyclopentane. Then you will arrange the substituents in alphabetical order. Next, we can also have um, alkyl groups attached to cycloalkenes. So the same rule with the cycloalkenes naming earlier, but we have additional group attached to it. So we have here an example. First, identify the name of the cycloalkane. So in this case, there's only one double bond. So you don't need to identify the location of the cycloalkene double bond. Combine the alkyl group and the name of the cycloalkane. So the name will be alkyl group is this, and this is and this is um cyclopentene. You combine these two words and you will get the name of the compound. So cyclopentene. So that's the name of our compound. Next will be the other figure. Here, only one substituent or one alkyl group is present. So this is methyl, and this is cyclohexene. You combine the two words, you add them. The name will be methyl cyclohexene. So as you notice, there are no numbers as locators. This is because there's only one alkyl group attached, and there's also one double bond in the ring or cycloalkene. Okay, so again, you just add directly the name of the alkyl group with the name of the cycloalkene, and you will get the name of your compound. For this case only, if only one alkyl group and one double bond is present. We can also have two alkyl groups attached to alkene. For here, an ethyl group, group. Then the name of our cyclane is cyclohexane. Or after identifying group, uh, you number them. So you will start your name with ethyl. You start numbering at the carbon. So carbon 1. Then the next carbon will be the one bonded with the double bond. So the direction after identifying the carbon will be going to the carbon uh, connected with a double bond. The priority uh, the next is so here because still is attached to it and the double bond start at 1. Okay, so we will prioritize numbering double bond. So our number now. We will now write our name of the compound. So cyclo- so this is not cyclohexane, this is cyclohexene. So cyclohexene, we will not write the location of the double bond because it only has one double bond. So we will directly attach the next um, alkyl group, which is meth. So this will be methyl cyclohexene. Then location of methyl is in carbon 3. Then ethyl, then location of ethyl is in carbon 1. So the name of this compound is 1-ethyl 3-methyl cyclohexene. Let's review. 1 is the location of your first substituent, ethyl. 3 is the location of your second substituent, methyl. Then the name of your cycloalkene. Okay. Another example. There are 3 substituents attached and there are 2 double bonds in the ring. So this is a very challenging uh, task to name the compound, but let's try. First is identify the names of the substituents or alkyl groups and also the name of the cycloalkene. So we have methyl, we also have methyl, okay? Then the name of the cycloalkene. Okay, so let me erase that one. This is cyclopentadiene since there are 2 double bonds. Okay, next, after identifying the name of the cycloalkene, you write it cyclopentadiene. So we use penta. We have letter A after pent because we have 2 double bonds, like the rule in the previous discussion or previous topic about cycloalkenes and alkenes naming. Here, after writing the name of the cycloalkene, write the location of the double bonds. So number them starting at this point, okay? Or question yourself if that will give you a small number for your alkyl groups or substituents. If we start here, I think this will not give us a small numbers. So let's say, let's think with other possibilities. Since we will start with ethyl to have a small number, yeah, I think that's right. But our double bond, high priority, gihapon ang double bond. What should we, where should we start numbering? Okay, I think I got it now. So we should start numbering at this point here. So 1, 2, 3, 4, 5. Okay? High priority ang double bond kaysa sa alkyl group. So nahon ninyo base ang number sa double bond. Dapat ang double bonds will have small numbers. So here, to have small numbers for double bond, I started at this point, this one. So double bond location is at carbon 1 and carbon 3. So we have small number for our double bonds. And next will be um, the alkyl group. So even though there are two methyls that will be dimethyl, we will always start with ethyl at our name. So we will write here next will be dimethyl. So location of these methyls are in 5, carbon 5 and carbon 5. Then after it, you write ethyl. Then location of ethyl is in carbon 2. So take note of that. The name of our hydrocarbon now is 2-ethyl 5,5-dimethyl 1,3-cyclopentadiene. So 2-ethyl 5,5-dimethyl 1,3-cyclopentadiene. So again, in this case, high priority ang double bonds kaysa sa location sa alkyl groups. Okay? So it's a very tricky problem. So yeah, if you practice lang, you can have this skill in identifying where should you start numbering your carbon. Okay, let's proceed to other substituents that can be attached to our hydrocarbons. So like alkyl, we can also attach some halogens to our hydrocarbons. So we have here chlorine, bromine, fluorine, and iodine as a substituent or substituents that will be attached to our hydrocarbons. So like this, we have here a structure with bromine and iodine atoms attached to a hydrocarbon. So in this case, same principle, you identify the longest chain. So longest chain will be this one. Then identify the name of the substituents. We have an alkyl group, we have bromine, and we have iodine. So the three substituents will be arranged in alphabetical order. So whatever letter starts first will be the starting uh, prefix. So CH3 is methyl, so that's M. Br is bromine, so that's B. I is iodine, so that's I. So B starts first at the alphabet, so we will start at bromine. So I will now directly write the name. So location of bromine. So our numbering will be starting at this point. I'll clear it. Our numbering will be here: one, two, three, four. So that's our longest chain that will be um butane. Okay, wait lang. Try that again. That's one, two, three. Oh wait. Okay. Then butane. Then the last um substituent is methyl. So you will write methyl next to it. Methyl. Location of methyl is at carbon 3. The next substituent is second to the last is iodine. Then location of iodine is in carbon 1. Then the first um, substituent is bromine. So location of bromine is also in carbon 1. So as you notice, we arrange the substituents in alphabetical order: bromine, methyl. So those are the arrangements. Location of bromine is at carbon 1, location in carbon, location of methyl is in carbon 3. Then the name of our last chain is butane. So same principle with the added uh, halogens. Arrangement will be in alphabetical order. Another example here, longest chain will be the chain containing the double bond, which is this one. So we have here carbon carbon 1, carbon 2, carbon 3, and carbon 4. This is methyl, bromine, and chlorine. So arrange them in alphabetical order. So the name of the longest chain is still butene. I'll delete the text so that we have clear. So carbon 1, 2, 3, 4. This is methyl. So this one. So longest chain name is butene. Location of the double bond is in carbon 2. Then next will be the last substituent will be methyl. So methyl. Location of methyl is in carbon 3. Then the next substituent is chlorine. Oh, no, no. We will not use the word chlorine, but chloro. We will use the word chloro in our naming. Okay, cut. Next example or next figure. So we have here bromine, chlorine, and also some methyl. So number them: one, two, three, four. I started number one at this point because it is the closest carbon to the double bond. So the double bond started at carbon 2. So that's why I put it there. Then the name of the longest chain is butene. Location of the double bond is at carbon 2. Then next or the last substituent will be methyl. So this is methyl. I will write it here. Location of methyl is in carbon 3. Then next, after then lastly, the first substituent is your bromine. Location of bromine is at carbon 4. Okay? So high priority gihapon ang double bond. So that's why we have this numbering. The name of the hydrocarbon is now 4 bromine, 1 chlorine, 3 methyl, and 2 butene. Okay? So this is for halogens as substituents or attached to the hydrocarbons. Okay? Lastly, we have this other substituent, phenyl, which is made from the removal of hydrogen atom in benzene ring. So it can be attached to a hydrocarbon. So the name of the substituent will be phenyl. So similar with alkyl. So phenyl. So we have this structure. For example, the longest chain here is this one. We have 3 carbons. We have we start one, two, three. So that will be propene. So we will not write the location of the double bond because it only has 3 carbons. So it's not necessary. Basta propene ang ato ang longest chain. Di na necessary ibutang ang iyahang double bond. Then you write phenyl as your substituent, but you have to specify the location of phenyl. So phenyl is located at carbon 2. So we have 2 phenyl propene. So the name of this hydrocarbon is 2-phenyl propene. Then another example, we have a mixture of alkyl group, halogen, and a phenyl. Then our longest chain is this one. So we have carbon here, carbon here, carbon here, carbon here, and a carbon here. Then we will start our number 1 at this point. 1, 2, 3, 4, 5. Then the name of that longest chain is pentane. Then you will arrange the substituents. You have methyl, you have chloro, Then you have phenyl. Okay. So next, mm, after pentane, you write phenyl because P is last. Location of phenyl is at carbon 3. Next will be methyl. Location of methyl is in carbon 2. Then lastly, chloro. Location of chloro is also at carbon 2. So the name of our hydrocarbon is now 2-chloro, 2-methyl, and 3-phenyl pentane. Okay, so that's how you uh, write the name of um, hydrocarbons with phenyl groups and also with some other substituents. Okay, so don't focus too much on this part because I might not be giving this as your quiz or as an exam because it will be so tricky. So focus more on the skill on how to number the longest chain. So naming pattern is follows this trend. So we have substituents location, substituents name, bond location, then the longest chain, then the suffix. It always follows this pattern. So you should know this. And also, don't forget to arrange the substituents in alphabetical order. Okay? And also, prefixes in substituents does not mean you have to base it on the letter they contain. So, base the letter on the name of the substituent itself, not on the prefix. Okay? That's all for today's discussion. Thank you for listening.